Problem 21. To solve this problem, let's first write out the pages she reads each day. On the first day, she read 1/5 of the pages plus 12 more. Let's assume the total pages is n. So the first day, she reads 1/5 n plus 12. And the second day, she reads 1/4 of the remaining pages plus 15 more pages, and that should be n subtract the first day. She reads 1/5 n subtract 12 multiply 1/4 plus 15. And let's simplify that. That equals 4/5 n subtract 12 multiply 1/4 plus 15. And that equals 1/5 n plus 12. So the second day, she reads the same pages as the first day. And the third day, she reads 1/3 of the remaining pages, which is n subtract the first day and the second day because they are equal, so they sum up to be 2/5 n subtract 24 multiply 1/3 plus 18 more pages. And we simplify this, we get it equals 3/5 n subtract 24 multiply 1/3 plus 18, and that equals 1/5 n plus 10. So we sum up the pages she reads for the first 3 days. That's 5n, 1/5 n plus 12 multiply 2 because the first 2 days she reads the same, plus the third day 1/5 n plus 10 plus the fourth day she reads 62 pages, and that equals n. Now we can simplify this equation. We can get 3/5 n plus 24 plus 10 plus 62 equals n. And further simplification, we get 2/5 n equals 96. And from there we get n equals 240 pages in total. Therefore, the answer is C. Problem 22. Let's assume the 3-digit number is nxm. Because the hundredth digit is 2 more than the units digit. Therefore, we have n equals m plus 2. Now we switch order of the 3-digit number and do the subtraction. That means it's mxn. Now the unit digit becomes m subtract n, because m is smaller than n, so m needs to borrow 10 from x, so we plus 10. And we substitute here the n here into this equation. We get it's m subtract m plus 2 plus 10, and that equals 10 plus 2 equals 8. Therefore, the single digit should be 8. Let's assume PQ crosses vertical axis at H. Because POQ is a semicircle, that means OH is perpendicular to HQ, and OH equals HQ equals smaller r, which we assume is the radius of the semicircle. And for the larger circle O, its radius is OQ. We assume that is capital R. So here we will have, because OQH is a right triangle, so R squared equals smaller r squared plus smaller r squared equals 2r squared. And the area of the small circle combined, the two semicircles combined, will be pi r squared, and the area of the larger circle is pi capital R squared. Therefore, this will equal to 1/2. The answer is B. Problem 24. Let's first compare the first two numbers, 10 to the 8 and 5 to the 12. To compare, we use division. We use 10 to the 8 to divide 5 to the 12. And this can be expressed as, because 10 equals 2 multiply 5, so this can be written as 2 to the 8 multiply 5 to the 8 divide 5 to the 4 multiply 5 to the 8, and we cancel this out. We get it's 2 to the 8 over 5 to the 8, and that can be written as, because 2 squared is 4, so it can be written as 4 to the 4. This should be 5 to the 4 in the denominator. 5 to the 4. And now we can see that because 4 is smaller than 5, so this is smaller than 1. That means 10 to the 8 is smaller than 5 to the 12. And then we can compare 2 to the 24 to 5 to 12. 2 to the 24 equals 4 to the 12, and it's smaller than 5 to 12. Now what's left is to compare 10 to the 8th and 2 to 24. Now we can again use division. 10 to 8 divide 2 to 24, and that equals 5 to 8 divide 2 to 16, and that equals 5 to 8 divide 4 to 8, and 5 is larger than 4, so this is larger than 1. That means 10 to 8 is larger than 2 to 24. So now we can say that 5 to 12 is the largest, 10 to 8 is in the middle, and 2 to 24 is the smallest. The answer is A. Problem 25. To solve this problem, we need to find out all the combinations for all the possible stairs that adds up to 6. First, we consider he take 1, 2, 3 stairs at a time, and they sum up to be 6. Therefore, the combination of the three numbers will be 3 multiply 2 multiply 1 equals 6. Then if he takes one stair at a time. That means he takes 6 steps. So that's one case for ones. And then he can take 2 steps at a time. So 2 twos. And then he can take 2 threes at a time. So that's in total 3 cases. And then let's look at if there's 1 3 and the rest is 1 1 1. In this case, the position of 3 can be in the first or second or third or fourth position. So the total number of combination is 4. And then we look at if he takes 1 2 steps and then the others is ones. In that case, 2 can be in the first position, second position, third position, fourth position, or last position. That's 5 choices. Now let's look at if there are 2 twos and the rest is ones. So 2, 2, 1, 1, they sum up to be 6. And we can have 2, 1, 2, 1, 2, 1, 1, 2. And we can also have 1, 2, 1, 2, 1, 1, 2, 2, 1, 2, 2, 1. And these are 6 combinations in total, and there's no other ways of climbing the stairs. So we sum this up. That's 6 plus 3 plus 4 plus 5 plus 6, and it equals 24 in total. The answer is E.